Welcome back, guys. In this video, we're going to be solving this very problem on beta function. My name is Dr. Avitech. Remember to hit the subscribe button, like this video, and share that across to your course mates. So what we're going to be doing is we're going to integrate this. But remember that we're trying our best to make sure that it looks like the standard form or the standard way of writing a beta function. So let's see if we can do that. We should be able to do that. So let's start. Now, these two problems are actually similar to each other. So I'm going to do the first one. Then for the second one, the only difference is this constant, 1/3. So if I multiply by a third, I should just get my final result. So let me start with the first one. So let's see how we can make it look like this very one. So the first one says the integral from 0 to 1, s squared, 1 minus s squared dx. So the first thing we should do, or we can do, is to say this is integral from 0 to 1, s squared, then 1 minus s squared. This square root guy you see, the square root actually means the power is raised to the half, dx. So you can see that it's beginning to look kind of like this. It's beginning to look like this 1 minus x. The only problem is this s squared should not be here. That's how the standard form should be written. This x should just be a single x. There should be no x squared. Let us remove the s squared by saying let u be equal to s squared. Now, if u is equal to s squared, you will notice that the limit will not change, because when you say 1 squared is still 1. When you say 0 squared is still 0. So the limit will not change. Let us find x. So when you make s equal to the formula here, when you make x the subject here, what is the opposite of square? That's square root, right? So the square root of u is equal to x. But remember that this square root of u actually means u to the power of half. So u to the power of half is equal to x. Now we've been able to get that. But remember that you also need to remove the dx. So if u is equal to s squared, when you differentiate u, this is s squared. So s squared is going to become 2x. And then you put your dx beside it. Now to find your dx, you need to divide both sides by 2x. So this is du divided by 2x equal to what? Dx. The only problem now is, after doing this, this side should only have u. But there's an x here. There's an x. So what I'm going to do is to make sure that I can replace the x right here with something that has u. So yeah, let me write it like this. So this is du divided by 2x. This is x. X is u to the power of half. And this will equal to dx. And I kind of have every single thing I need to solve my integral. So this will become the integral from 0 to 1, s squared, but x is what? X is u to the power of half. This is u to the power of half times 2. And this is not x, so this is times. So let me just use a dot for that. So that's s squared. Okay, let me use this one, s squared. And then 1 minus, this s squared is u to the power of half. Or this is just u. So save myself the stress. 1 minus u, and that's raised to the power of half. And then dx. But remember that ds will not be written anymore. Instead, ds is du divided by 2u to the power of half. Okay, let's see. So this will cancel out this. This is over 2. So this over 2 can come outside. So this becomes 1/2 integral from 0 to 1 of u. We'll just be having u left, or you could just say u to the power of 1. And then 1 minus u to the power of half. Now this is du divided by u to the power of half. Now if this is u to the power of half and this is u to the power of 1, if you are dividing, you need to subtract the powers. So this is half integral from 0 to 1, u to the power of 1 minus half, 1 minus u to the half, du. Now what is 1 minus half? When you remove half from 1, you will still have half, because half plus half is 1. So this is half integral from 0 to 1, u half 1 minus u half du. And finally, this is looking like our beta guy. It's looking like our beta guy. So it's looking like this. So this is half beta of, now be very careful, this is half. Now this is m minus 1. Remember that you always add 1 to this. So what is half plus 1? That's going to be 3 over 2. Then this is half again, plus 1, that's 3 over 2. Look here, half plus 1, put over 1 here. The LCM is 2. 2 divided by 2 is 1. 1 times 1 is 1. Plus 2 divided by 1 is 2. Times 1 is 2. When you add this up, this will be 3 over 2. Okay, so this is what we have. Now this will be half times, now let me express this in terms of gamma. So this will be the gamma of 3 over 2 times the gamma of 3 over 2 divided by the gamma of 3 over 2 plus 3 over 2. Now this is half times, okay, what's the gamma of 3 over 2? Remember that this is not, it's not a whole number. So there should be a way to do this. Now the gamma of 3 over 2 is 1 over 2 gamma 1 over 2. Remember that when you want to express this with the recurrence relation, you're always going to be subtracting 1. We've done gamma functions before. So you could take a look at the intro to this. So we're always going to be saying minus 1. That was why I said 3 over 2 minus 1. That's 1 over 2. Gamma 1 over 2. Times, this is same thing again. So this will be 1 over 2 gamma 1 over 2. Divided by, okay, let me make the half much more bigger. Let me put the times at the middle. Now 3 over 2 plus 3 over 2 is just 3. 3 over 2 plus 3 over 2 is just 3. Because you could say 3 plus 3 is 6. Then 6 over 2 is 3. So what is the gamma of 3? The gamma of 3 is just 2 factorial. Because you have to say minus 1. So 3 minus 1 is 2 factorial. So this is 1 over 2 times half times half is 1 over 4. So this is 1 over 4. Now, the gamma of half is root pi. So this is the square root of pi times the square root of pi. Because we have it in 2 places. It's a special value. Remember I said that when I introduced this topic. So the gamma of half is a special value, and that's root pi. Divided by 2 factorial is just 2. Okay. Now, this 2 times this 2 here is 4. So this is 1 over 4 times, I can now write this as 1 over 4 root pi times root pi. So 1 over 4 times 1 over 4, that's 1 over 16. Root pi times root pi is pi. So the answer for this is pi over 16. I'm going to put equal to everywhere if that changes anything. Okay. So the answer to this question is pi divided by what? 16. Pi divided by 16. Now, the second part that has the constant of 1 over 3, that has that constant. How do we do this? Integral from 0 to 1, 1/3 of s squared root 1 minus s squared dx. Yeah. Now, this 1 over 3 can come outside. So this is 1 over 3 integral from 0 to 1 of s squared root 1 minus s squared dx. So what would this now be? This will become 1 over 3. Remember that we have solved this part. This part, we just did it and it was pi over 16. So this is pi over 16. Now 1 times pi, that's pi. 3 times 16, that's 48. And this will be the answer to that very problem. Remember to hit the subscribe button, like this video, and share it across to your classmates. This will be all for this video. I'll see you in the next one. Bye.